Okay, welcome everyone. This is another session with Coliance and IBM. This is one of our Coliance Connect events. It's a 20 to 30-minute chat with a number of experts around a different challenge in the world of integration. Today's topic is around from queue to clarity, and it's looking at IBM solutions such as MQ, ACE, Sterling, and also a solution that Coliance have built called Opsis, which gives you business process visibility across a number of different vendors. Well, in fact, it's vendor and system agnostic. So yeah, I think that might be quite interesting for the audience as well. To do some introductions today. So as I've already said, I'm Stuart Power. I'm the Sales and Revenue Director here at Coliance. Coliance are an IBM Gold partner in the integration automation space. We've been an IBM partner for about 15 years and in business in the UK, but operating globally with companies typically within the supply chain, logistics, and finance markets. We also have some guests with us today from IBM. So Dave, if you'd like to give a brief introduction.
Hi, my name's Dave Page. I work in technical sales in IBM within IBM Automation Integration. So I specialize basically, as it sounds like, in anything to do with integration. So MQ, ACE, data power, all of that sort of stuff. I've been with IBM since 1999, doing exactly the same job as I do now.
Excellent, thank you. And Martin?
I'm happy about it.
I'm Martin Howson, and I've got a very similar job today, but he's the senior one because I've only been here since 2000.
Excellent. And John Hawkins.
Yeah, hi there. Ex of IBM, funny enough, from the Hersley lab where some of these guys come from. I'm an MQ and ACE guy originally, but since leaving IBM, I don't want to say how many years ago, let's say 10-ish, been working with various business partners, both IBM and non-IBM business partners. I'm now responsible in Coliance for the Opsis business monitoring tool.
Perfect. Thank you very much, gents. So why don't we kick off for those people that might not be quite as familiar with what is IBM MQ? What is its purpose? What does it do? Who uses it? Dave, Martin, if you'd like to pick that one up.
I'll kick off. Okay, what is MQ? If I just quickly share a very simple basic slide, which I hope we can see. You can see that?
We can.
So what is MQ? Well, think of it like a way of sending data or messages from any sort of application to any other sort of application almost anywhere. Cloud, on-prem, any operating system, any sort of data up to a maximum of 100 meg, but you can wire them together, so you can send more than 100 meg if you want. Very rare. Very, very securely, very transactionally. We do not lose messages. And anybody who says we do can come and have a word with me, because I've been doing this for 25 years, and there is only one way to lose a message in MQ, and that's to blow up the server room. Basically, you have a bunch of objects in MQ when you install it. There are things called queues, which are where the messages, funny enough, queue. There is a queue manager, which, funny enough, manages queues. There are channels, which are links between application A and application B, or system A and system B, going across the network. And there's a whole bunch of very clever things you can do with these messages going over channels and into queues, and all managed by the queue manager. And as we can see on here, there are multiple formats or transaction types to handle any sort of scenario, any sort of use case you want to hand, where you've got application A. Let's say it's a web browser and you're running a bit of Java or Java server pages, and it needs to get in touch with this ancient old mainframe where there's a bit of COBOL running, or a KIX transaction to do, I don't know, a mortgage quote. So you scrape all your information off the screen, tell your age, how much money you've got, and how much money you want, and all this sort of good stuff. And it needs to get that off to a KIX transaction or COBOL, or even, God forbid, assembler. How on earth does it manage to do that? Well, glad you asked. MQ, Java application on the web browser, packs into an MQ message, connects to a queue manager on the mainframe or even locally, and says, right, you see this message I've got here? I want it to end up firing that kicks transaction on the mainframe. So I want you to take this message and put it on a queue called old mainframe queue number 1 and tell me and let me wait here until I get a response, i.e. another message coming back the other way from that kicks transaction saying 125,000 quid and that's your lot. And that's basically the sort of scenario, which is very common. That's called request and reply. But you may not want that sort of model for your messaging. You might want publish and subscribe. I'm a share system. I'm real-time pricing IBM share. I'm changing that price maybe every couple of seconds, or even more if it's been as it's doing recently. And I will run an application that's monitoring that real-time ticker feed from the stock exchange, and I'm passing that data out. It's $250, it's $249, it's $248, etc. But I only want to send it out to people who are actually interested in it. So there's a bunch of applications that say, oh, we really need to know the IBM share price every second. So I, as application B, will subscribe via MQ and tell MQ, hey, I want this topic, shares IBM from the US stock exchange. And MQ says, okay, I'll bear you in mind. As it's processing messages coming out of the real-time feed handler on a particular topic, it will drop that in a topic-based queue, and only the applications that have put their hand up saying they want that sort of information, i.e. they have subscribed to that topic, will get those messages. That's the second sort of application messaging model. So we have request, reply, publish, subscribe. And then there's good old, very, very, very common fire and forget, where an application using MQ receives data from another source. It could be anything, updates on a database, real-time events from, the Internet of Things. Somebody asks for an insurance quote and throws out messages with the data that's going to help the end application figure out the answer or figure out an event, saying, yeah, send this message to everybody. Just drop this message in the queue called insurance data, or the queue called customer order came in. And don't stop, don't wait for a reply, just completely asynchronous. So there's multiple models you can do. With the queues themselves, there's all sorts of clever stuff you can set on that. So you can say things like, I don't want it FIFO. What's FIFO? First in, first out. I can change the order. I can set priorities on the messages. I can, when I'm setting request reply, wait for the response to come in and send a response rather, back to whoever sent in a request message. I can have things called trigger queues, where as soon as a message comes into the trigger queue, it does something. It sends another message out to wherever you want, saying they've started trading or we've got an order. You can set trigger levels. You can say, wait until you've got 6 messages in the queue and then do whatever. Queue managers themselves are very clever. You can cluster them and end up with what's called an MQ queue manager cluster, where you're handling multiple thousands of messages a second, say, and you want to minimize any downtime. So you define a cluster of queue managers spread across multiple servers, multiple hardwares, multiple clusters if you're on the cloud, so that when the server goes down, you don't lose everything. You carry on, and when that queue manager returns and comes back up, the server's powered back up again, it will automatically rejoin the queue manager cluster. And over, Martin, anything you'd like to add about that?
There's a couple of things I'd like to add. The other thing about MQ is that it's a transaction engine. So say, for example, you want to send, if a transaction occurs and that transaction has to be reflected in 2 applications, what you can do is you can send 2 messages, one to each application, but do a 2-phase commit across those 2 messages, for example. So they either both go or neither go. So that avoids getting into a situation where half a transaction's happened. And then when an application picks up a message, it can also pick up a message and update a database under a transaction. So, for example, application picks up a message, tries to update a database. If it fails, MQ will automatically roll the message back. So you don't get these situations where, for example, a banking transaction, a debit's happened, but the corresponding credit hasn't. So that's quite an important bit of MQ. It means that you don't lose things. You don't lose things while you're processing them. And if multiple things all have to happen at the same time, you can coordinate those using an MQ transaction. And it's pretty simple. You go MQ begin, send that message, MQ commit, and that's it.
Okay.
And so that's quite an important bit.
Yeah. Now, one of the very common thing back in the late 90s, early 2000s, when I first started looking after MQ, was there was a lot of overnight batch processing of stuff where you collected data or you collected transactions or orders or whatever it was during the day, and you ended up with this enormous file of transactions that you had to process overnight, and you had 1 hour and 20 minutes to process it, or you're in big trouble. MQ, on a lot of cases, got rid of that and turned instead of stacking up messages to handle overnight, process those through MQ messaging as they occurred. Another thing that MQ was very good for and where it got its start. But like Martin was saying, one of the main places where any financial market, any bank, anything to do with money, MQ was in there because it was solid, it was reliable. You get paid, you want to make sure you've got paid. You take money out of cash point, you want to make sure it all comes out once, please. All this sort of good stuff. MQ loves finance. Anywhere where you want security and transactionality.
Yeah, no, it makes perfect sense. Clarity, visibility of kind of what's happening, but knowing that it's happened as well and having the confidence in there, that's really important.
The question might also arise, how is MQ different from a Kafka event? And I also, one of the things that I say, an MQ message is an instruction to a system to go and do something. And when that thing has been done, the MQ message is then removed because you don't want to do it again. Whereas a Kafka message has got a long life because it might be used several times. So MQ is banging on the door saying, you go and do that. And when you've done it, I'll cross it off my list. And that's another way of looking at MQ.
Yeah, it's like that publish and subscribe with the share prices. There's often a Kafka feed of events. It's gone up, it's gone up, it's gone up. Oh, it's gone down, it's gone down, it's gone down. You catch those Kafka events and turn them into MQ messages if you want, or just pass them straight through in a publish and subscribe by transforming a Kafka event into an MQ message and publishing it out to non-Kafka systems.
Yeah. And the other thing about MQ is to say the messages are not long-lived. They live until the transaction has happened, and then when it's happened, it's removed.
Or the expiry date is passed. They use another field on the message.
Yeah.
MQ's got first-class support for Kafka now, doesn't it?
Yeah.
Yeah. So it understands Kafka and can talk with it directly, which is great.
And there are connectors as well for Kafka and MQ. So what you can do is you can send an MQ message, and that will generate a Kafka event. There's a Kafka connector inside IBM event streams. Sorry, there's an MQ connector inside IBM event streams.
Okay.
Yeah.
So, John, obviously, we come from the world of enterprise integration, MQ being one of the solutions that we service and support our customers with. But you've personally taken over kind of the build of a solution here at Coliance called Opsis. Do you want to explain in a brief sentence or two about Opsis, what it does, how it relates to what we've just been talking about in regards to MQ?
Sure. Yeah, absolutely. I think I'd just say the usual question I hear so many times is, where's my message? Dave eloquently said, we don't lose messages. That's absolutely right. MQ doesn't lose the message 9 times out of 10. Most of MQ administrators' job is proving that they didn't lose the message. It's crazy. So essentially, coming from that integration background with the likes of enterprise service buses and all that sort of stuff that sit over the messaging environment, I recognized that there was a real need to track and trace messages going over my system. And it's not just a messaging problem, it's a generic problem which says, where is my order? That's how I like to euphemize it with, or because it's okay saying I've got a messaging system and the CPU is high or the memory is high, but what is actually flowing over my system? What is the business that is running over my system? And I can pretty much guarantee you that not many people in your firm will know what is flowing over your systems. Because I've seen so many situations where at 3 o'clock in the morning, when all hell's broken loose, you'll be sitting there go, right, what system should we bring up first? Well, I think that customer runs their business process on this system, but if we did that, then that would, you don't know. You don't know what queue is being used necessarily by what firm, by what business process. So to get that clarity, not only over things like MQ, but in the Sage and the SAPs of the world and the Red Prairies, we designed a system called Opsis, which starts off at the business monitoring level. So I'm not monitoring how MQ is running. I'm not saying MQ is really running well, or ACE is running well, or SAP's running well. What we're doing, we're saying what is actually running over these systems? What is my business process that's running over these queues, that's running over that pub sub? So we track the documents, so let's call it a business order, that goes over MQ, that goes over your security gateway, that goes through Sterling B2BI, whatever it may be. And we say it got there, it got to that system, and it's gone from there now. It's not there. It's now gone into SAP. And then we go look at SAP and we say, is it here? Yep, it's here. Oh, it's errored. There's been a problem in actually creating that order in SAP. So we give you that whole business view of how your business is running over your systems. And we give that in the context, not of document ID 37296, or not over, oh, we're busy today. But if you want to say, where is order 39725? We say, yeah, okay, it got there. It got to be, it was order received, it was created, it was released. We use that sort of language. We don't say things like, oh, it's gone over that queue, or it's sitting in that database. We say, where is that document in my process, my business process?
Sure. Okay. And that's system and vendor agnostic, as you kind of said
100%,
earlier. So.
Yeah. Oddly enough, we do use little bits of Kafka, but don't let that scare anyone under the hood to connect into any system. We don't care whether it's Red Prairie, Sage, SAP, MQ, ACE. We can get events from any system. We get those little, one of our customers described it as the breadcrumbs that an application leaves. So as a document flows over MQ or flows across SAP or flows across whatever it may be, we say, oh, grab that breadcrumb, tracking ID, and file it away. And that's how we do that.
Perfect. Thank you, John. So obviously in preparation for today, I tried to ask our customers for a number of questions, and they've posed me 3. So yeah, very handy that we've got 3 of you today. So I'll pose these questions and we can work out if one of you want an answer or if it's a combination. So the first question is, how are organizations rethinking integration in the era of hybrid cloud? And what role do IBM, MQ, ACE and Opsis play in turning those message queues into actionable business clarity? Anyone want to pick up on that?
So one of the things that we're noticing, there is a move away from having one great big ESB that contains all your logic to almost like micro ESBs. And this has been brought about because people have started to deploy on containers. So what they might have is they might have an integration engine for a particular project running in a particular container. Now for another project, they'll have a different container running. Might be the same, it'll be the same integration software, but what that means is that it means that organizations are more agile, because if something changes, you don't have to test every single integration across the whole company. It's encompassed within a project. And the other thing is that we're starting to notice that people like automated testing and deployment. So things driven from Git, for example. So rather than manually creating an integration engine, they like to be able to drop the integrations into a Git repository and have that build your container and deploy it and test it. So that's there's a move towards that. I mean, it's a big job to move towards that, but once you're there, it doesn't half free your hands up to do interesting things rather than just maintaining what you've got.
Yeah, and I think that was one of my biggest frustrations when I first started, many years ago, we won't say how long, when I first started doing integration, I sat there and I went, all this to do what? Where's my business? How much time am I spending worrying about my infrastructure versus actually running my business and creating my applications? It happened in the application world years ago, where we started focusing in on the application writing and making that faster, and the infrastructure just became the infrastructure that just works. And that's now happening with this containerized world. We're just saying, I don't care where it runs on, just that just happens for free. Let's worry about my integration, the actual work, my business. So it's a good move, thank goodness.
And the other thing we're seeing, obviously, the requirement to integrate with lots of cloud applications as well. And some clients even split their integrations across cloud and on-prem, because got one of my clients in the factories, they run integration, but for things like dealerships and things like that, they run integration on the cloud. So they separate the two out.
So, yeah. Makes sense. The second question I've got here are, what are the biggest challenges? Excuse me. What are the biggest challenges enterprises face when scaling MQ and ACE and general integration, particularly around security, visibility, and performance? What are the biggest challenges they face when it comes to security, visibility, and performance?
Well, I would guess it's around visibility, because you can scale these applications very easily. You just need to know that you've got to scale them.
Yeah, the scaling is has been in, for example, in ACE or Message Broker or IBM Integration Bus, whatever you want to call it, since it started. This great scalability in terms of the integration servers, what used to be called execution groups within those. So you could take an instance of what's now ACE, and you could scale it horizontally or vertically right from 20, 30 years ago. And that still applies right now. So it's all very well saying you can have multiple containers, but the ability to add or remove cores, for example, on those cloud installs is very important. And if you could do that dynamically as required, so if the load goes up, you start adding cores. And if the cloud system can do that itself, then that overcomes a lot of worry and administration and management. As for the security, that's because a lot of ACE was based in MQ, and MQ has, for example, advanced message security built into it these days with MQ Advanced. You can secure it to death. You can basically have, digital certificate checking. You can have full encryption using digital encryption keys at both ends as part of an ACE message flow, for example.
And one interesting thing as well is that, again, I've got a client whose attitude is no one talks to my MQ directly from the outside world. And so what they've done is they've put a data power layer in and said, you talk to data power, and data power will put the message onto my queue after I've made sure that you're a trustworthy source of information and after you've verified who you are. So I call it it's the bouncer.
Yes.
You're not coming in here with no shoes sort of approach. You show the right credentials and I'll let you in. And
and it also prevents denial of service attacks like SQL injection. There's a famous client who I won't name who if they had had data power after I demoed it to them, could have avoided a lot of grief and a great amount of loss of data. It's very good because data power has a whole bunch of pre-built, loaded in rules for checking for all the known and all the latest denial of service attacks. And each time we'd identify a new one, we add a new rule. It's a sort of schema, if you like, for data power to say, right, hold on a minute. We've got two new scenarios that deny service. We'll just run your request through these checks before we say, okay, you're kosher, you can come in.
Yeah. And John, I guess with Opsis, you obviously you give users the relevant role and scope, responsibility and visibility to see those business processes. Is there any other
absolutely.
areas of Opsis you can think of?
No, I think that's the key point. I mean, obviously, I'm not securing the message as such. For Opsis, we are absolutely security first because I don't want to be sending information about your business around the system when I don't have to do it. So we leave as much data in your system as possible. We take out the tiniest little tracking event that we have to, which frankly, out of context means nothing to anyone. Would anyone get a hold of it? And when you're actually accessing Opsis, we have full capabilities to really, really tight, granular security. So if you're allowing a business partner to look at the state of their order, let's say, going through Opsis, then you can absolutely state exactly what they're going to see. They don't see anything other than what you want them to see, whether that be, they might not even see the tracking ID. They might just see where it is in your pipeline. If you don't want them to see that it's in error, well, don't show them it's in error. Just show them the good bits about your process. So, absolutely.
Yeah, that's good.
And then one other point, which may be where Opsis can help a lot, is that one of the areas I've seen in terms of problems of scalability is when a back-end system won't go fast enough. So we are trying to drive a back-end system quickly. So I've got one example. A well-known retailer has a loyalty card, and you put the loyalty card in or swipe it at the till, and what that was doing is that was updating an SAP system at the back end. Now at lunchtime, when everybody's out on their break and they're buying sandwiches and whatever, that SAP system could not keep up, so there were long delays at the till. So what we did is we designed I'd say, well, implement it asynchronously. If SAP is busy and you're not getting a response back from it, then stick it onto an MQ queue and then do it asynchronously, and then you won't get people standing there at the till waiting for a response. But it would have been handy to know at what speed we could drive SAP before the system was built in the first place.
Yeah. So you're potentially going into what we call our SLA functionality in Opsis. So within Opsis, we can also track at any given point, a very particular point in your business process, to speed of it, an SLA. You expect it to go at such and such a speed. If it goes over this length of time to do this process, then tell me about it. It's an issue for me. So you can get warned of all those sorts of things in advance. And that's really useful for a lot of people because they didn't realize actually where their slow points were, frankly. And not only that, if you lose a message, I don't mean MQs lose a message, let's be clear, but if something's gone wrong in a back end system somewhere and the message has disappeared into a black hole, having an SLA over that back end system. So let's say, I expect that operation to have completed in 1 minute. And suddenly it's just disappeared. There was no actual error in the back-end system. It just disappeared. Having that SLA will warn you it disappeared. You won't know what the error is. You'll have to go deep and dive into the back-end system. But for the first time, you'll be actually say, especially as an MQ guy, no, wasn't me. I sent it. I can prove I sent it. Something happened over there that you're not trapping, Mr. Customer.
Okay, perfect. And the final question here, guess without spilling future roadmaps, etc., is looking ahead, how do you see messaging and integration platforms evolving? And how do companies best future-proof their architecture? So obviously, you think for the integration world, IBM just acquired Web Methods a little while ago. Obviously, there's a number of integration technologies already there. Yeah, anyone want to pick up on that?
Yeah, one thing that's sort of started already on the roadmap for all the integration products is the addition of AI. For example, in ACE, you can now say, I want to map two data formats. Here's one in XML and here's one in JSON. Um, Go and do your best in mapping the data fields without me having to draw arrows between the fields. The other one is in ACE Designer, you can integrate SaaS solutions. Now, there's pre-built into ACE a whole bunch of pre-built, say, Google Sheets to SAP or any A to B pre-built ones. But if you've got a challenge of integrating different SaaS opportunities or systems, rather, you can just basically say, and type in English that you wish to connect and integrate these two and describe the systems that you want to integrate. And along with how they integrate, is it the creation of something in system A needs an update in system B? You can basically type that in, and it'll be what's the ACE Designer will actually do is it'll say, I think this is the best fit for what you're trying to do. And it'll point you that way and point you to a pre-built integration and lead you through how to fill in the blanks. I think the other thing, like you said, with the appropriation of web methods, we've now got an even a higher level. We tend to, it's actually called a control plane that doesn't just show you your web methods integrations that are deployed, your App Connect integrations that are deployed, your MQ systems. It shows you everything you've got from one pane of glass and allows the control of all of it. And that's I'm using AI under the covers as well. So it's this idea of an overall single pane of glass control place or control plane that anybody can use just to find out how's things going. Is everything up? Is everything processing? Is there any backlogs anywhere? What's the average response time on these APIs at the minute? Which API is the most requested? How much money are we making? Because we're charging 10p for every API call that goes out of it, and all this sort of good stuff.
No, that sounds good.
Yeah,
and I think that's go on, Karen.
So the other thing that we're seeing is that a lot of clients want to do automated testing as well. So rather than you sitting there firing transactions at the new version to see if it's the same as the old, the results are the same as the old version, people are wanting to automate that, because that basically is a pain in the neck, having to check whether it's all working. The interesting stuff is, let's go and do something new. Let's offer a new service. And what I'm actually seeing with one client in particular, because they automated what I call the plod work, they are spending a lot more time now on looking at business problems and trying to solve them. So why are these things sitting around after they've been ordered? What can we do to get things out of the door quicker? And so that they're actually spending time delivering new functionality rather than keeping the old stuff going.
Yeah, that makes sense.
I'm going to add in Opsis advert there. That's again where some of the SLAs and understanding from a business perspective, not from a system perspective, what's going on helps so much. And I'd go back to Dave's point. I think the reason these iPaaS is very important is because everything's so flipping complex. What we've all actually talked about today is composability. And we split out what was one engine or a few engines into lots of little parts. We're running on little containers. So we get a microservice proliferation, which is an absolute nightmare when you're actually doing it for real. When you're getting in these massive companies, it scales up to a certain level, but then it gets great complexity. So we will be building more and more tools which simplify that complexity.
So 10 years ago, we used to say, don't do point-to-point integrations, because if you've got lots of different APIs to call, you've got this spaghetti of everything talking to everything. Now what seems to happen is people call it a microservice now, and it's all acceptable. So I guess that's going to be a problem about managing all of that lot in the future.
Yeah, and that's where the iPaaS is coming in. I think you're going to see more AI actually helping in that, the dull stuff, which we shouldn't be bothered with, frankly, the management and potentially self-healing of all of these things as well. It's going to go down. It's absolutely, it has to go down the route because it's just so complex.
Perfect. Thank you very much, guys. I'm conscious of our time for this session. That's been very informative. So that was the Coliance Connect event with IBM on your from Q to Clarity. So yeah, appreciate that again. Thank you very much, guys.
Cheers, Joe.
Great talking to you. Cheers.